So as the final video for Unit 2, this is your review for the end of Unit segment. Okay, our first question. Which graph represents a proportional relationship? Well, the two things that I know about proportional relationships as a definite is that it has to be a straight line, and it has to go through the origin. So when I look at these two graphs, it appears that both of them are straight lines. However, only one of them actually goes through the origin, which is this one right here. So I've chosen the correct one, and I've explained why. Straight line goes through the origin. Our next question. This graph shows the weight W of G large grapefruits, which is a proportional relationship. Okay, so the first thing I know is that a grapefruit weighs 1.25 pounds. Well, I don't know that. I should say I'm selecting the true statement. So this is the first thing that it says to me. So I know that that, of course, is the unit rate that they're talking about. So the first thing I need to do is discover the unit rate. So when I look at this, I see that G is at the bottom, or our x-axis. So remember, this is X, which is grapefruits. And W is the weight, which is my y-axis. Sorry about that. I clicked on something wrong there. Oh, did it again. I don't know that you can see that. But anyway, it's all set. Okay, so I've got X and Y labeled, my grapefruit, number of grapefruits compared to the weight. And I want to set that up as a unit rate. So I know that my number of grapefruits is 40, and the weight, well, according to this graph, if it's accurate, would be 50. I know I always have y divided by x, which is y over x. In this case, would be my w over g, weight over grapefruit, which would be 50 over 40, which is another term for division there. I use my calculator. 50 divided by 40, of course, is 1.25 per 1. So 1.25 pounds per 1 grapefruit, which is exactly what A says, so A is correct. Okay, the next one says 1.25 grapefruits weighs 1.57 pounds. So I would simply take my ratio that I have figured out here, my unit rate. I know that's W over G is equal to 1.25 over 1. This is telling me 1.25 grapefruits. So that tells me that this bottom number is 1.25. I say to myself, how do I get from 1 to 1.25? Of course, I multiply times 1.25. So I'm going to do my top number, 1.25 times 1.25. Again. What? Okay, sorry about the interruption. 1.25 times 1.25. Again, put that right in your calculator, and you should get a number of 1.5625. If I round that, it does in fact become 1.57 because, well, technically I round down, but this says 1.57 is approximately the same. In weight, I would round up, so this, in fact, would be true. And circle B as well. Okay, next. 1.25 pounds is the weight of 10 Somehow my word got cut off, but I know on your paper it says 10 grapefruits. So again, I'm just going to use that very same ratio that I used above. I know again weight over grapefruit is equal to 1.25 over 1. And they gave me both of these for this particular one to see if it's correct. So I'm going to use my bottom number because that's a 1. How do I get from 1 to 10? Well, of course, I multiply times 10. So I multiply this number times 10. And I don't even need my calculator, but you can use it to double check because I'm just going to move that decimal one place to the right. That is going to give me 12.5. So C is also true. Moving right along, D. I've got 12.5 grapefruits, weighs 10 pounds. Okay, carrying right along, weight over number of grapefruits, I know is 1.25 over 1. This tells me 12.5 grapefruits. So if this is equal to 12.5, how do I get from 1 to 12.5? Multiply times 12.5. 12.5 times 12.5. 1.25 times 12.5. So I've multiplied this times 12.5 is going to give me 15.65 pounds. 15.625 pounds. Either way, whether I wrote a 5 or a 2 is kind of irrelevant because this wants it to be 10 pounds. So I know that D is not one of the true statements. For your last one, the 0.54 is on the graph of this relationship. So they're saying as if there's a straight line from the origin, because we know we've been told it's proportional, up to, and that's a sketch, it's not an exact straight line, that 5,4 would be on the graph. So it kind of looks like, if I look at this, just eye it, this is where 5 would be on X, because remember I run then jump. So 5,4 would be a little bit below this line. It does not appear that it's on the line, but let's double check. I know that all of my coordinates are always written in the order of X then Y. X then Y. So if I say that's 5, 4, I know what my X and my Y are. That's always written WG. Remember that's Y divided by X. So I've got 4, in this particular case 4 over 5. In my original that they gave me, 40 over 50, let's do the exact same thing with that. That's XY. In that same order is 40, 50. Y over X would be 50 over 40. If I reduce that, I know both are divisible by 10. I would end up with, that should be 40, sorry about that, 5 over 4. Clearly, these are not equal to each other, so E is also not a true statement in line with the original graph. So, my final answer would be that A, B, and C are true statements. D and E are not true statements. Along, our next question. Aiden rode his skateboard at a constant speed. He rode 1 mile in 4 minutes. Which of these equations represents the amount of time, T, in minutes, that it takes him to ride a distance of D miles? So for this one, I'd actually like to set up a nice little chart here. I know it's always distance then time, or it should be anyway, distance and time. I'm given that he rode 1 mile, which I know is distance, so I'm going to put a 1 right here, and time is 4 minutes. So here's my chart that they gave me. So I know that in order to write an equation, I simply put in a variable and send it through. So if there's a d on this side, what happens to d to get to the t? So remember, in this direction we always multiply. So I'm asking myself, what do I multiply 1 by to get to 4? Well, 1 times 4 is 4. So I ask myself, what is d times 4? D times 4, of course, is 4d. So I know that for one of my equations, I'm going to have 4d is equal to t. Because remember, once I send that variable through, I then set it equal to the variable at the top of that column. So my first equation would be t equals 4d. Or if you write 4d equals t, same exact thing, that would be fine. Next, if I don't know d, but I have t, and now I want to send t in this direction. I know when I go from right to left, I always divide. I know I found that my constant proportionality to be 4, so if I'm now going to divide by 4, that would look like this, t divided by 4. And I further know that dividing by 4 is the exact same thing as multiplying times 1/4. So I know that my equation t over 4, or t divided by 4, is going to be equal to d. T divided by 4 equals t. T divided by 4 equals d. And I also know that dividing by 4 is the same as multiplying by 1/4, so I could also write that as 1/4 t equals d. So these are the equations that I know that I can write. So if I look at the ones that they've given us, t equals 4d is the first one. Oh, there's that right here. So I know A is correct. T equals 1/4 d. Well, that is not the same as what I have here, and I can't just move it. Remember, when I go from one to the next, it's the opposite, which of course is what this is. These are opposites of each other, which makes them equal. So opposites on opposite side of the equation makes them equal. You need to be careful what I say there. So therefore, B is not true. The last two, C and D, have adding and subtracting. Well, I know in order to be a proportional relationship, which is what this is, because it says it's a constant speed, which makes it a proportional relationship, I know that there is not going to be any addition or subtraction. There's only multiplication and division, so therefore that eliminates both of these. So in this case, the only one that is correct and matches this situation would be A. Here we have two lines representing the amount of water over time that two tanks that are also the same size are filling. Which one is filling more quickly? Well, I know when I look at graphs that the thing that is happening most quickly is always the one with the steeper slope. Is always happening faster. So if I look at these two, obviously the one